Okay, perfect. So let's now have a look at an example of a problem where we need to find a gradient. So this is an average distance where how long it takes. Let's say I have a runner. So we've got a runner here. And this runner, we want to see how long it takes this runner to basically complete a certain distance. So for example, here you can see that it takes this particular runner 5 hours to complete a distance of 400. Okay, so what you do to be able to find the gradient, you pick 2 points. So this is 1 point, so this is at 0, 0, and that's another point at 5 and 400. And then within these 2 points, you try to find the gradient by saying, okay, what is the height of between these 2 points? How much has my straight line? What is the rise of my straight line between these two? And your rise here, so it's gone from 0 to 400. Okay, so if you think about your y-axis, it's gone from 0 to 400. Okay, and how much has it gone? What distance do you have in the horizontal direction? So that's basically just your 5 minus 0. So if you think about the horizontal axis again, so you've gone from 5 to 0. So it's taken 5 hours. Okay, which is going to be just 80. Perfect. So now what you need to remember is it actually doesn't matter which 2 points you choose. So you could have chosen, for example, this point, which was corresponding to 2.5 and 200. And then you say, okay, let me take this point and that point. If you did the same thing, then you say, okay, what is the height of this? It's 200. What is its run? And that's 2.5, and that gives you 80 again. So basically, so long as you have 2 points on this line, no matter what 2 points they are, whether it's these two or any of the other ones, they're still going to give you the same gradient, and it doesn't make any difference. Now, what you need to remember is whenever your graph is going in the positive horizontal direction, so what that means, so this is called a positive gradient, right? And what that means is basically whenever you have positive gradient, your graph, as your x values are increasing, your y values are also increasing. Okay, so if this was 1, then that would correspond to, let's say, 1 on my graph. If this was 2, then that would correspond to 4 on my graph. So you can see that as the x values are increasing, the y values here are increasing as well. So the opposite of that would be a negative gradient. So what would a negative gradient be? So let's say something like this. Now here, as your x values are increasing, your y values are actually decreasing. So if you think about it here, if I'm here at minus 2, let's say, then my y value is, let's say again, 10. This is not 2. Okay. All right, so this is minus 2, and that's at 10. But once you get to 0, your y value is actually decreased, even though your x is increased. And by the time you get to here, which is your x value is 3, your y value has decreased to 0. So you can see that as your x value is increasing, your y value is decreasing. So this is basically the definition of a negative gradient.